So today we are going to look at Quicksort implementation, how Quicksort code looks like, and just for the explanation purpose, let me just copy this array so that I can explain you how I am going to implement what I am going to do. So basically in Quicksort the main thing is that we choose a pivot element and then we just keep on partitioning the array. So firstly, there can be multiple implementation in which we can choose pivot element at start, at end, or at the middle. But the implementation that I'm going to show you, that implementation I'll be using first element as our pivot element. So pivot element that we have will just store that in our pivot variable, and we make use of two pointers, I and j. I will be pointing to the element at first index and j will be pointing to the element at the last index. So what happens over here is that we start from the end, and as the first element is the pivot and the ith index, so we'll keep on comparing that if the element present at end index, that is the element at jth index, is less than the pivot element. In this case, yes it is. So we'll just assign I to j. In that case, we'll just not will not swap, but we'll just assign it. So 17 will come over here, and now I will move forward, j will remain put. We do not have to worry about 20 as we have stored it in the pivot variable. So now we'll look for the element that's greater than our pivot element, and as I is at first index and the element present at I index is greater than 20, so again I value is assigned to j variable. Now j will hold 45 and now j will be decremented. Okay, now we'll look if the value present at j index is less than the pivot element. No, it's not. So we'll keep on decrementing until we find the value that's less than the pivot element. And as now j is present at this index and the value is minus 12, which is less than pivot. So now I will be j value is passed to I. Minus 12 will come over here. Now I will move forward. Now I is compared with j as I is compared with 20 as I value is not greater than 20. So I'll move forward. When I move forward, we can see that I will be pointing to the same index as j. That means I and j are on the same index, and now we will compare if i's value at I is greater than pivot. No, it's not. Now I will move to the next index. So this is where our break condition will come to the rescue. When I crosses j, will just come out of the loop. We do not have to compare as we have already checked with j the rest of the elements. And now j will be, whatever the index that j will be pointing to, that's the right index for our last index. Now j was pointing to this index, second index. Alright, So this is where we'll assign our pivot element. Now our array will be divided into two halves. That's the left subarray, that's the right subarray. This is where the partition will come. And now we will just apply the same by using recursion to the left and to the right subarray. So let's see the implementation, how the code looks like and how it will work. Let's just write public static void, call it quick s. We pass in the integer array input. We'll pass the starting index and the end index. Now, as it makes use of recursion, the first point to remember what recursion is to write the precondition. And the precondition here would be if n minus chart is less than 2, then we do not need to do anything, we'll just return. So what does this statement means is that if there's only single element left in our array, then we can just come out of our loop. So next, let's write the recursions for the left and the right subarray. I'll pass in the input array, the start index for the left subarray, and for the left subarray, after the partition of after we have find the first right index of the pivot element, we'll have our left and the right subarray. So for that, we first write the partition function. Let's call it pivot index. We'll create a separate partition function. We'll pass on the input array, start and end index, and this function will help us to partition and to locate our pivot element at its right index, the first pivot element. After that, we can just recursively call this method, these two methods, so that we can do the same for our left and right subarray for all the elements in the left and for the right subarrays as well. So we'll loop till pivot index, as that will be our left subarray, and for the right subarray as well. Pass on input. It will start with pivot index plus 1 and go till end. This is for the right subarray. So now let's write the partition function. Public static int, it will return integer value. Let's call it partition integer array input int start int end. Now let's write the partition function. So firstly, for the pivot element, as the first thing we do is just assign our pivot element into our pivot variable, pivot equal to, so that we can hold our pivot value. And that's our first, we are considering first element as our pivot element, so we'll just use that. After that, we use while loop while I is less than j. Okay, so let's just assign the variables. Int I is equal to start and int j is equal to end. And while I is less than j, so here what we need to check is another while loop we use, while I is less than j and the element that's on the input at index minus j, whereas as we started in the from the last or from the jth index, as we are having the and assigned to a j variable, we'll first decrement it because j holds the size of the array and the elements are always less than one less than the size of the array. So we'll just that's why we'll just post decremented our array, and we'll keep on decrementing until or unless we find a element that is less than our pivot element. And while j is greater than equal to pivot element, we will not do anything until that. We'll just decrement our j variable. So that's why there's no loop and there's no body to while loop. Well, what we need to do is just decrement j while the element to the left of the pivot are greater than the pivot element. And if in case this loop is broken or will come out of this loop, that means there's some condition. Either it could be I has crossed j, or we have found element that's less than our pivot element. So for that, if if it's not crossed I, then that means there's element that's smaller than the pivot value. So I'll just reassign it. That means input at index, I will just assign whatever the value is in at the index j to the ith index, as I showed you in the example. Now we'll start looping from the beginning, that was from the ith index. Again we'll use while loop here. Check the case condition, and in this case we'll pre-increment our I value as we are starting from 0th index, and we'll keep on incrementing I while the elements are less than or equal to pivot value. In case we have found the element that's greater than the pivot element, then we'll come out of that while loop, and then we'll check if it I is less than j. That means this condition is not violated. In that case, we have found the element that is uh, greater than the pivot element. In that case, we'll pass it to jth index, whatever the value is at ith index. So that's all. That's most of it. Let me just write some more. Okay, so after that, we'll hold or whatever the value after this will come out of this while loop. That means I has crossed j, so j value will hold the right index of a pivot element, so we'll just pass to that. Okay, so we'll pass on pivot is equal to input at index j, and we'll return j. As we return j, that's passed to in pivot index. So then again, based on a pivot index, we'll have left and right subarrays. So this is how this function will work. So let's call it in our main function. I've already written it, but for the sake of this video, I'll write it again. Quicksort q is equal to, we are creating the object of our quicksort class. We'll call the function now q dot quicksort s We pass in the array, and the starting index is 0 and ending index is array dot length. So this for loop will just output the array values. So let's run and see. Okay, so I've done something wrong. What did I do? Let's see. Y is equal to j, j is equal to I. Let's just write it the other way because we'll put pivot value to our jth index, not. Let's see if it works. Right, it's working. So I just wrote it the other way because the pivot variable is holding a pivot value. So j is the right um, index at which our pivot element should be. So we'll assign our pivot element to the jth index. So that's it. That's about the code of Quicksort. That's the implementation. I use first index as our pivot index. You can use any. There could be multiple implementation for single algorithms. So that's it.